Hey everybody, Miss A here, coming at you again. It's a little bit more CodeHS today. So we'll be going over lesson 12. And the title of that, right, while loops in Karel. So this is always a really interesting topic when it comes to these certain very, very basic kind of structures in coding, right? So sort of already we've done functions, we have done for loops, we have done if statements, we've talked about if and else kind of statements, and they're all fine. They're not too bad to work with, and the consequences of getting it wrong are pretty minimal, right? The only thing that happens is Karel doesn't do exactly what you wanted him to do. You know, not the end of the world. You go back and you change it. While loops are kind of fascinating because they're the first real structure that we teach you guys that can, make your computer crash, which is something we never want to happen, right? We always want to make sure that our computer is running nice and healthily and can actually process the things that we're giving it. We don't want to give it things that make it like seize up. And that's kind of what a while loop can do if you don't do it correctly. So, right, this always does tend to be one of those things that gets, it's still one of those very, very basic structures, but it's sort of one of the last ones of that you are taught, precisely because, a programmer needs to at least know a little bit about what they're doing in terms of how a program steps through its instructions, right? You need to have done for loops already. For loops are much harder to screw up. They are like, you can still technically crash a computer with a badly written for loop. It's just a lot harder, and especially you can like avoid it very easily without thinking too hard. While loops, like, you actually do, like, you don't just have to be able to write JavaScript correctly like it is with for loops. As long as you write it correctly, everything works fine. With while loops, it comes down to a much more conceptual thing, right? Like, and it's a problem that all teachers deal with insofar as, right, like a programmer is kind of like a teacher to a computer. It's sort of the same way, is that, when we have, how to put that? I don't know where I was going with that metaphor, to tell you the truth. But, in a sense that, like, it's important. You want to be careful with the kinds of things that you're instructing your students to do, right? You want to make sure that, like, and it's always easier to make sure of that with a problem that has like kind of clear, this is how you do it correctly, this is not how you do it correctly. I think it's a reason why, say, a lot of people who find writing very difficult is that it's there's so little in the way of like actually concrete rules. Like, there are millions of suggestions, there are millions of like examples of good writing that you can throw at a person, but like, if you're a writing teacher, and I remember teaching writing back in graduate school, and trying to grade an essay being like, what's wrong with this, is oftentimes very difficult to put, in a kind of a clear way that anyone could understand. Whereas, things like computer programming are much different, right? The rules are kind of set in stone. Playing with the rules in certain creative ways can still definitely, like, lead to dangerous results, but fundamentally, right, the rules going in, and it's a matter of testing like what you can get away with within those rules, which I think is why a lot of people who don't like things like math and computer programming tend to not like them, because I think like maybe it can feel very constricting. So, if you feel that way, if you're the type of person who, math is just like not your thing, it feels kind of, makes your skin crawl just thinking about it, like, is that a big reason why? Let me know in the comments, let me know on Google Classroom if you're one of my students, however you want to reach me. So just let me know, is that one of the big reasons that you have for not liking math, right? This idea that it kind of feels like a straitjacket, where you're sort of like stumbling in the dark, and like no matter where you put your hand, it feels like there's another wall there. I can definitely see that, right? Like you sort of get overwhelmed with all of the rules and you don't know like just how to move. So, you know, different things for different folks. So this is a very long roundabout way of saying that, you know, when it comes to while loops, you have to think conceptually in terms of your problems, right? It's not just a matter of like obeying the rules the way that things have been so far, right? You basically just don't want to, like, they just, sorry, got an email, got a little distracted there. So with a while loop, you know, you want to make sure that everything you're doing is not just meeting kind of the rules as is necessary, right? So far, that's how you've probably been breaking programs when you have been, is you write something, you don't obey the rules of JavaScript, a little red thing shows up there, and the computer says, I don't understand. Or really, it'll say that in its own way, which is syntax error. That just means I don't know how to like read what you're telling me. And now like it's not so much about that, because now there's gonna be like a whole bunch of different ways to screw up, even if you write everything clearly and correctly. If anything, it kind of, that's what opens you up to the danger. Like if you write a bad while loop and you can catch it because you misspelled something and the computer and like the program didn't run, that's a good thing. You know, we always want to catch these early, but a lot of times we only figure this out by testing, and you'll probably see that you might screw up your while loop, and if you do the kind of the wrong thing, your computer will seize up. You might have to hit on a Windows PC Control-Alt-Delete. I forget what the code is on Mac. I haven't used a Mac in a while, but yeah, you might have to use that and kill your browser and open it back up. This might happen. So you really do now like want to think through what you're doing, and you have to think it through in terms of the problem, not just the language. Okay, you have to think about the problem because that's where it's going to get you. So the problem with while loops, as we're going to discover, is a while loop is basically a way of, as I open this up, oh yeah, thanks again to CodeHS. You guys make great videos. Thank you so much. Please, you know, check out all their videos. They are available on YouTube. They can explain this stuff much better than me. I'm just, you know, giving a second option to my students. So let's take a look. So a while loop, right, fundamentally is like if you tell somebody, keep doing this until something, right? Like keep doing, say like if you have a contest, like I don't know, like a pie eating contest or something, right? It's like the instruction is keep eating pies until you hear a buzzer. That's it. Or sort of, I guess if you want to really expand, it's like wait until you hear a buzzer, right? So you keep waiting. There's no buzzer, there's no buzzer, there's no buzzer, there's no buzzer. Now there's a buzzer. And so you're like, okay, so now the instructions are keep eating pies, right? Eat a pie, eat a pie, eat a pie until you hear a buzzer. So now in your brain, you're going to be thinking, okay, no buzzer, eat a pie, no buzzer, eat a pie, no buzzer, eat a pie, no buzzer, eat a pie. Buzzer, stop eating pies. Now it's okay to vomit on the floor if you need to. Sorry, gross imagery. But that's kind of what a while loop is, right? You're basically saying, I want you to keep doing something until, you know, some other thing happens. Or really, it's sort of like, it's actually gonna, maybe that's a bad example, because really it's sort of like, keep doing this thing as long as this thing is true, right? So we more have to think of it in terms of like, keep eating pies as long as you haven't heard the buzzer, right? It's like saying, what do you need to do, or what do you need to notice to know to keep going on? So instead of knowing when to stop, right? That's how a human wants to think. What do I need to see to know that I should stop? For the computer, it's what do I need to see to know to keep going? And so let's take a look at what that looks like in practice, right? So for instance, with Karel, one of the things they're going to make you want do with him a lot is keep moving until he hits a wall or hits a barrier. This is not really something that you can do in for loops unless you know very specifically what the situation is, right? What if, you know, he lives in different rooms, and say like to get to one wall he might need to move 14 times, but like to hit a different wall he would have to move 10 times, and then a different wall would be a different amount, right? So for loop is not really helpful there. For loop kind of needs to have that number determined in advance. Either you give it the number or you give it a way to calculate that number, but it's not really like, you know, updating too much, right? That final condition is kind of baked in. With while loops, that's not really true. With the while loops, right, a while loop can run 0 times, it can run 1 time, it can run 10 times, it can run an unlimited number of times, right? That's essentially what makes it crash, right, is when the loop doesn't know to stop running because the condition never turns off, okay? So, right, repeat as long as the condition is true. So like the way that I was putting it was like, what needs to be happening for you to know to keep going, or for the computer to know to keep going? Not when to stop, but when to keep going, okay? So this is going to be a very common thing that you use, right? It's always shocking to me how many students just like don't watch this part of the video and don't know to do this when it's, you know, and then get lost with the assignment. Like, this is what you're going to be doing a lot. While front is clear, so basically front is clear, this function is Karel's way of telling, like, is my front clear? And that's a yes or no question, so he's always going to get a yes or no answer. Or really, in computer speak, we like to say true or false question. When you ask him the question, hey, Karel, is your front clear? He's going to look in front of him, whatever direction front happens to be, and he's either going to say yes, the front is clear, or no, the front is not clear. Like, front is clear is true, or front is clear is false. If it's true, he moves, right? So think about what that means. Front is clear being true means he has room in front of him to move. So that's what's going to tell him it's okay to move. Like, it's basically like saying, go ahead and move as long as nothing is in front of you. If there is something in front of him, right, front is clear is false, then nothing happens. It works a lot like with the if statement, right? The if statement works the same way. When the condition has to be true for an action to happen. A while loop is really kind of just like an iterated or like a repeated if statement. So that's going to be a good thing to look for as you're coding. I keep doing that. Oh, I guess that's it. So this is going to be a big thing you're going to want to look for as you do these while loops. Like when you're programming, and you might notice, you're like, okay, Karel needs to make some kind of a decision here. He needs to, you know, decide whether he can keep moving, or he needs to decide whether to keep turning, or he needs to, you know, decide something like that, or whether there's a ball there or not yet. And you have to be able, like, that can sound like an if statement, and it can sound like a while loop. The question in your mind is, how many times is he going to have to make that decision? Does he need to make that decision just one time? And say maybe, you know, he might make one decision that tells him to do a lot of things, but the decision itself is not going to be there, right? So for instance, we could have this be like, if, so, you know, say for instance, we have like while front is clear, move, right? So we know that's going to make him move from left to right, like until his front is not clear. What if, for instance, like we just want him to like see if he can like, if his front is clear, he can move, but, like, if it's not clear, then he should just, like, spin in place. So the way we could do that is say, like, if front is blocked, right? So there's a function that's going to be kind of the opposite. If front is blocked, turn left. But say, for instance, we could put that in a for loop. So we could say, you know, turn left, but do it in a loop that runs 12 times. So like 3 full spins. So that's where, say, like, he's going to turn left a bunch of times. The action is repeated, but the decision only happens once. He just decides, okay, like, basically, either I can move, like, if front is clear, move, else, or, like, something like that, right? Some sense in which, like, sure, he could move, but, like, if his front is blocked, then he should do this repeated action. One decision that leads to repeated actions. While loops are different because with the while loop, it's always, like, decision, action, decision, action, decision, action. Whereas, like, what I was talking about before is, like, decision, action, 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 action. So, right, kind of different there. But, so you're going to have to kind of think through your problem and think through the repetition you're trying to create and the kind of decisions you're asking of the computer. And that's going to tell you which of these to use. If a decision is made one time, you use an if statement. Whether what that if statement leads to is like one action or a looped kind of repeated action. For a while loop, it comes down to, like, you're gonna have to make a decision every single time. Say when he's moving to the end of the screen, it's like, is my front clear? Move. 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 Always he's making a decision every single time before he does something. And anytime you have a problem like that, that's going to scream out for a while loop. So here we go. We're going to have that quiz that you'll need to finish up. And now we get to move to wall. So this is the one that they showed, right? So in the start function, we have this while loop, while front is clear, move. And so here we can kind of see, all right, is my front clear? Yes, true. So we go inside, move. He moved. Ask the question again, is the front clear? Yes, move. Front is clear? Yup, go ahead and move. Front is clear? Yup, go ahead and move. Front is clear? Yeah, go ahead and move. Front is clear? No, this time front is not clear. So he's going to just jump over that final move. Because if he did keep moving, he would hit a, he would get an error that says, you know, oh, Karel crashed into the wall. Let's look at the docs. So if we look here, right, we've got commands, functions. Let's look at conditions. And here we have Karel conditions. These are essentially the kind of observations or decisions that he will understand. When you get to, like, the sort of the more, like, real JavaScript, you will be defining those rules, which is always going to take the form of a comparison. Is this thing the same as this other thing? Is this thing different than this other thing? Is this thing greater than the other thing, right? So you're typically comparing either, you know, sort of two values, two different things, and making a decision that way. For Karel, right, they, you know, we kind of have these pre-made functions that act like those conditions. So let's take a look, right? There's basically, here we have maybe what you might call like the positive side. Here's the negative side. These are like front is clear, left is clear, right is clear. These ones are the opposite. Front is blocked, left is blocked, right is blocked. So there's always going to be one version of each. Balls present, no balls present. And again, you want to pick the versions of these that keep the action moving. So here, right, he should keep moving as long as the front is clear. What if we did the opposite? Because this is something that I see students doing quite a lot. What about picking the opposite? So now you might be thinking like, oh, well, like he should keep moving until his front is blocked. That kind of makes sense. Well, let's see what happens. Okay. Is the front blocked? No. Front is open, so nothing happens. The loop doesn't even start. Okay. Another thing that I see students do is picking a condition that doesn't have to do with what you actually want Karel to look for. Like one thing I noticed that's very interesting is, say for this kind of case where you're thinking like, oh, move as long as, you know, your front is clear, there's nothing blocking you. But then they might use like, no balls present. Okay, so this is like an interesting thing, and this is one I definitely have seen students do a lot. So this, for some reason, is a very, I guess, obvious thing to do for a lot of people, which I don't entirely get, but there's definitely something there. So if I do, if we go through this, so basically we're gonna ask, okay, are no balls present? Yeah, no balls there. No balls present? Yep, absolutely true. There are no balls there. 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 And then he moves, right? Because even in the last spot, there's still no ball there, right? So this is the thing, right? When you use a condition that's not really related to the problem at hand, that's not related to the actual things that you want Karel to be looking for or that you want your program to be thinking about, when you use irrelevant things like that, it tends to run into this problem of not knowing when to stop, because this is like a light switch that never turns off, right? So that's the problem. We want the while loop to stop eventually. It has to stop eventually. Otherwise, the program will crash. Okay, so here, let's try this. Let's say no balls present, and instead, right, because with move, he hits a wall and he'll eventually stop. What if I do something like turn left, where there's nothing baked into this that would actually stop him? Well, let's try it. No balls present? Okay, turn left. No balls present? Okay, turn left. No balls present? Okay, turn left. What are you noticing? That's never going to change. He's always going to ask the same question, and every time he's going to get the same answer. This thing does not know when to stop. If I had actually hit run, my browser would have crashed, or would have kind of like seized up, and I would have had to close it and reopen it, and it would have been really annoying. So that's why I was very careful. So this is actually one reason why I highly, highly, highly suggest doing this when you're trying to test out your while loops. Instead of just immediately running your program, step through it one by one, because if you notice this pattern where he like can't escape a loop, you're gonna notice it without crashing your computer or crashing your browser. So it's like the safer, easier way to do this. So big Miss A pro tip there. So that's it for me. You have 3 exercises in this unit, and this is like, you know, other than this random hurdles, which is kind of a bit of a challenge in lesson 13, lesson 12, like this is, once you get over this hurdle, you're pretty good, okay, in terms of finishing this out. So hopefully more and more of you are going to be getting here soon as our term ends. You know, if you have any questions, please pop them into the comments in the stream on Google Classroom. You can email me if you're one of my students. I'm not going to give out my email. So, you know, hopefully this was helpful. Let me know. Otherwise, I will hopefully see you guys next Tuesday, barring something coming up, where we'll go through lesson 13. All right, everybody. Thanks.